Okay, let's talk. Okay, um, let's get started. Okay, good morning. Uh, Now this is the last time that we will take class, and then next week we will have our final presentation, and I'll spend some time to wrap up the entire course. Okay, so now this unit is entitled Assumption and Simulation. We actually already learned how to do assumption and simulation last week. Okay, if you still remember that when we try to connect prediction to decision, right? You still remember this slides, right? Okay, and that's actually our homework assignment last week. Okay, so this week we were kind of like extend what we have done in last week, try to give you a more complete discussion about the assumption and decision. Okay, about how to use assumption and simulation to make decision. Okay, as I say that this should be the most important part in business analytic. After you build the model can do prediction for you, right? Okay, in our last week's homework assignment, what are we predicting? What did we predict? We predict the quality of care for the diabetic patients, right? So what is the result of the prediction? We basically predict the probability that for each patient, right? We predict the probability of poor care, isn't it? Okay, so that is the prediction. After the prediction, you basically get the probability for each of the patients, right? You get the probability for each of the patients. So there is a distribution of that probability, okay? So now you need to make a decision, right? You need to decide a threshold, right? For those who the probability is higher than the threshold, you want to do some treatment, right? Okay, to prevent excessive risk, isn't it? That's what we tried to do last week. In last week's homework assignment, I let you do assumption on the payoff matrix, right? Isn't it? If you still remember the, you should remember, right? You just did the homework assignment, right? In our last week's homework assignment, I want you to do this homework, right? Okay. So maybe let's warm up. Let's warm up by kind of recall the detail of this exercise, right? So I'm saying that if we have a series of action, if we have a series of treatment that cost 5, 10, 15, 20, 35 per patient, okay? We have a set of different treatment, and the cost of the treatment are different, okay? And also the effect are also different, right? If we do not take any action, for those poor care patients, it costs us in average 100, right? But if we use this treatment, the risk of course will reduce from 100 to 70, 60, 50, 40, and 30, right? These things are assumption, isn't it? Okay, assuming that we have this treatment, and first of all, we want to decide which treatment should we use, right? And the second thing we need to decide, we need to select the target, right? We need to just select a set of patients. So we want to apply that treatment, right? And the third thing is we need to estimate the payoff, right? We want to estimate the result. We want to know that after we apply this treatment to this selected patients, what is the expected outcome, right? That is what we are trying to do. That is what we have tried to do in last week's homework assignment, right? Okay. So so which of the treatment is the best? You have done homework, right? You should know that, right? Which one is the best? Say louder. The fourth one, right? How did you do the decision? You basically, for each of these treatment, you need to build the corresponding payoff matrix, right? Isn't it? For example, for the first treatment, it costs only five. It costs only 5, right? But its effect is to reduce the 100 risk down to 70, right? So we go to the simulator and we do some adjustment, right? Okay. Actually, usually these two numbers would not change, right? Because that corresponding to that map to the no action type of things, right? If you do not take any action, the expected value will not change, right? Okay. So if you take action, this is the cost of the action, right? And this is the cost of the action plus the cost of risk, right? So for the first treatment, what is this number? For the first treatment, the cost is 5, right? So what is this number? Here is like we take action to those who are good care, right? Isn't it? So for those who are good care, you basically there's no risk, of course, in the beginning, right? So after you apply a treatment of cost 5, your net payoff will be -5, isn't it? Right? So this actually represents the cost, and this actually represents the cost plus the reduced risk, isn't it? Okay. So the first treatment is going to reduce the cost from 100 down to 70, right? So so here we need to change it to 5 because of the cost, right? And here we need to change it to how much? Anyone has a number? This is the cost, right? And what is this one? This one is the cost plus the reduced risk. So how much should it be? See, in the process that you can determine the fourth treatment is the best, you should already do this exercise, isn't it? Right? So for the first treatment, with the cost of 5 and the reduced risk of cost down to 70, how should I adjust this TP? Anyone? You can do some discussion now. Try to warm up a little bit, right? try to recall what you have done last week. You get my point, right? The payoff metric actually come from your business scenario, right? Your business context. So you need to like make some assumption. So before you can do the simulation, right? So how should I adjust this slider to reflect the situation of the first treatment? What? How many? 130? What? Why you say 30? This is the first treatment, and it can reduce the risk from 100 to 70, right? So where does the 30 come from? 100 minus 70? No, it's not the case. See, if you apply, even after you apply that treatment, right? You still have the risk of 70, isn't it? Right? So so in this case, when you apply the treatment has a cost of 5, isn't it? And after you apply the treatment, there is still a risk of 70, right? So in this situation, you should have a payoff of like minus 75, isn't it? Right? If you do not apply any action, you know that in average, this poor care patient will cost you 100, right? But after you apply the treatment, that 100 will reduce to 70, isn't it? Okay? But however, the cost, the treatment has a cost, right? And in this case, it costs 5, right? So this sales should be how many? Yeah, it should be 75, right? Okay. So this sales is actually the cost of risk. The cost of treatment. And this sales is the sum of risk plus treatment, right? Okay. So in this scenario, you can actually try, when you apply apply the same procedure to all of the 5 treatment, you should see something like this, right? This is drug treatment 1, 2, 3, 4, 5, right? Like treatment 1, 2, 3, 4, 5. Now they are in different color, right? Okay. So the payoff matrix is actually the assumption, right? It's the assumption. And with every assumption, we do the simulation, right? When we try to simulate the situation, now based on the assumption, right? We simulate the situation that we do the cutoff at 0, cutoff at 0.1, right? Cutoff at 0.2, up to the cutoff at 1, right? When we set the cutoff at 0, right? Implies that we are applying the treatment to all of the patients, right? Because all of the patients, their expected probability is higher than 0, isn't it? Right? So if we set the threshold as 0, it means that we are doing the treatment to every one of the patients, right? Okay. And as you can see that, especially for drug fly, it's actually very bad, right? Okay. Compared to doing nothing, right? If I set the threshold at 1, it means that I do nothing, right? Because 1 is the largest probability, implying that all of the patient, you do not do the treatment. right? Okay, you can see that whatever treatment it is, right? The point is actually the same, right? Because if you do not take any action, right, whatever the treatment is, will not affect your expected return, right? Isn't it? So all of this phi curve will kind of like converge into a single point. If you do nothing, right, whatever the treatment are, whatever the possibility are, they will not change your expected payoff. Okay. So if you do a treatment, if you do it too much, you actually have a worse, right? You actually when you take action, the result of the action actually could be worse than doing nothing, right? For example, in this case, if you do nothing, the cost is here, right? If you do it to all of the patient, you actually make it worse, isn't it? Right? In order to have a better situation, you need to do selective treatment application, right? You need to apply the treatment to selective users, right? And that's why that is the reason that we need to do model and do prediction, right? Okay? So when you simulate, now according to the assumption, when you simulate in a range of threshold, then you can see that for all of this treatment, the highest point implies the least cost, right? So this light blue one is actually drug 4, right? Okay, so it actually has the highest payoff, right? Isn't it? Now the good thing of this GG plot is actually partly is you can actually zoom in, right? So you zoom in so you can see that. Oh, drug 4 is here. Okay, right? So you can see that drug 1, 2, 3, 4, 5, and the highest one is actually drug 4, right? And if you do the cutoff at 0.36, you'll have the like maximum expected payoff at minus 2720. Okay. In this case, the maximum payoff is negative because we are talking about cost reduction, right? You're trying to get the minimum risk of cost, right? So even the maximum expected payoff is still negative. You're reducing it, but you cannot make it like positive, right? Okay. So that's basically what we have done last week, right? Okay. And in this process, we actually use we actually have already applied assumption, right, and simulation to help us make decision, right? Isn't it? Okay. Again, this is the prediction, okay, and this is the assumption, right? We need to like simulate different cutoff, right? Okay, different cutoff imply different confusion metric, right? So you will see a curve like this, isn't it? Okay. So you will see a curve for each of the different treatment, right? So and this curve will help you first of all select the instrument, right? Select the treatment. And second, you help you to identify the optimum threshold, right? And third thing is they help you to choose the patient, choose the subject to apply the treatment, okay? And the fourth is will help you to estimate the return, okay? So this is basically the process from prediction to decision, right? And that is why we need to learn programming, okay? If you only learn, if you use the tool like SPSS to do the model, okay, how the, it can only build a model for you, and it can do some prediction for you, right? But it would just stop there, right? But in order to do managerial decision, you will need to do the assumption and also simulation before you can before you can do the managerial decision, right? And that's basically the most important thing in this course, okay? So today, what we want to do is we would like to extend we would like to extend the assumption and simulation process to a more practical, more realistic, but a little more complicated case. Okay? We actually want to do the same thing today, but we are going to apply it to a more complicated, but more realistic and more practical case, which is the Tafang data set. Okay? The Tafang data set. If you still recall the Tafang data set, in the case of Tafang, we are going to do some marketing analysis. Okay? We are going to do some marketing analysis, right? Because of time, we do not have enough of time to cover how to do the predictive model in the Tafang database. Okay, so we assume that I will give you the model, right? The model is already built, so we basically have two model. Okay, assuming that you have hired someone, right? So using the Tafang data to do two model, right? And the first model is to predict the buying probability. Okay, so for each of your customer, you can predict that the probability that this customer will buy from us in next month. Okay, that is the first model you can build, right? Okay, because you already have the buying history, right? So you actually can use the historical data to predict whether or not each of these customers would buy from us, right? So buy or no buy is actually a categorical prediction, right? And as I have mentioned again and again, the categorical prediction is basically predicting the probability of each of the category, right? So basically, we are building we already built a logistic regression to predict the probability that each customer will buy from us next month. Okay, so assuming that we already have that model ready, right? Now the other thing is actually the buying amount. Okay, buying probability is whether this customer will come to our store, right? But when he come, the amount that he buy would be different, right? For each of the customer, right? So we have the second model to help us predict the amount that he would buy if he come to the store, okay? So this time we have two model instead of just one, isn't it? Right? We have two model. One model predicting whether he will buy, and the other model predicting that how much he will buy. Okay? For each of the customer, we have this prediction. Okay? Now, if you recall our midterm exercise, right? We actually, after we do the exploration, we we would choose some. We basically have choose some target variable, right? You want to set a focus on your marketing, right? And you set some objective. For example, I would like to set my focus of marketing on the age group of 30 years old, okay, 30 to 40 years old, right? That is your target customer, and you know you also need to set a kind of like objective, right? For example, you try to raise their buying probability by 5%, right? So you choose a population, and you want to do some marketing on them, right? For example, you can like kind of like deploy a coupon, right? You can like do some promotion, right? You can do some advertisement, right? In order to kind of like bring up the buying probability, isn't it? Right? Okay, so you apply some marketing instrument on some of the customer, right? It's similar to that you want to apply some treatment to some patient, right? In the marketing context, you are applying the marketing instrument to some of your customer, right? And the marketing instrument will cost you something, right? Okay, if you want to give out a gift, right? If you want to give out a coupon, if you want to like do some advertisement, it actually costs you something, right? Okay, so the cost of the marketing instrument is different, right? And you need to do some assumption, right? You need to do some assumption on the effect of the instrument, right? For example, if I give out to make it simple and concrete, let's say that we are giving out a coupon, right? A coupon has a face value, right? If I give the coupon of like 5 NT dollars, do you think it would be effective? Well, it's very limited, right? Okay. If I give out a coupon of face value like $50, well, some people will be attracted, right? If I give out a coupon of like $500, okay, I mean NT dollars, okay, it would be very I would say in a grocery store, it might kind of attract most of your customer, right? What happens if I set the face value of coupon to $5,000? Do you think that it would have a much better than 500? Maybe not, right? Because after the 500, most of the people are already been attracted, right? So you will see that there will be a cost-effective curve, right, for each of our marketing instrument, right? And you need to do an assumption on that cost-effective curve, right? So if you can do the assumption like that, you can simulate, right? You can simulate that what is the maximum, what is the optimum strength of the instrument, right? The strength of the marketing instrument is actually represented by its cost, right? In our coupon example, the more cost I spend, right, the more effective it is, isn't it, right? But the curve is not linear, right? You need to do some assumption, so you know that try to like do assumption on the cost-effective function of the marketing instrument, and then use this assumption plus these two prediction, we can do simulation, right? So after the simulation, it will help you to choose the instrument, right? You might have several marketing instruments. I mean, you can send out coupon, you can do cost promotion, you can do advertisement, you can do some event in your store, whatever. Okay? Then you have different marketing instruments, just like you have different treatment, isn't it? Right? And for each of the treatment, you will have a cutoff, right? You will kind of have a cutoff, but this time you're actually not setting a treatment or not, right? You are basically choosing the do I want to, for each of this customer, do I want to give him the treatment? Do I want to give him the coupon, right? So if you can selectively send out your coupon, right? For example, you are using a mobile app to distribute your coupon. It could be very selective, right? You can actually deploy the coupon to a selective population, isn't it, right? So the simulation would also help you to choose the correct population for distribution. And then, of course, it will help you to estimate the cost and return, right? So this week we are going to expand the diabetic patient case to a more realistic, more practical case of retail marketing. Okay, so the difference is, like, first of all, we have two models instead of one, right? Okay, we are using probability as well as the numeric model, right, to predict the buying probability and buying amount for each of our customer, right? And we would use assumption to kind of assume the cost effective, the relationship between cost and effect of each of our marketing instrument, right? Okay, then we will do simulation, right? And the result of this simulation would help us to do these three things. We choose among the marketing instrument. We choose among the customer, and then we estimate what is the optimum outcome that we can expect. So you get the point? Any question up to this point? You get my point, right? You get my point, right? Okay. So because this is already the end of the class, end of the course, right? And actually, this is the thing that I would like you to do in your final presentation. Okay. We in this semester, we try to give you a complete business analytic process, okay? In the defunct retailing store data set, right? We try to, like, kind of let you experience a complete business and an analytic process, right? In the first half of the course, we are doing data preparation. Of course, in the beginning, we spend some time to teach probability and programming, right? So, but the reason that we need to learn probability and learn programming is we want to do the things, right? We want to do data exploration, so we can see a holistic picture, so we can see the business situation of our company, right? And based on this holistic, based on this kind of like a a systematic view of our company, right? When you can see the global trend, when you can see the global structure and phenomena, you can set your strategy, right? So you can do a planning. So you can see your feasible strategy. That is what we have done in the first half of the course. And in the second half of the course, we're actually using model to do prediction, isn't it? Right? So the focus is no longer the entire company, right? Okay. The focus is on each individual customer. So you see the difference, right? When we do exploration, we try to capture the holistic, systematic phenomena for the entire company, right? And that is at the strategic level, right? But the strategy will not realize itself, right? Unless you do some operation, isn't it? Right? If you only have a strategy, it will not realize itself. You need to do some operation. But in order to do operation, you need to choose among different instruments, right? You need to choose the target customer that you want to use this instrument, right? And in order to do that, you need to estimate, right? You need to estimate the cost and effect of this thing. In order to do that, you will need to use model, right? Okay? And as I already explained to you, right, we basically only have two types of model, right? The first type of model is actually predicting probability, predicting type. It's kind of like predicting whether this customer will buy from us next month, right? Okay. The second kind of model is numeric model, right? It helps us predict the, for example, the amount that the customer will buy from us, right? So with this model, you can actually predict down to each individual customer, right? You can predict the behavior of a customer, okay? So if you have this prediction, then you need to do, in addition to this prediction, you need to do some assumption on the instrument that you want to apply, right? In the marketing context, you actually different kinds of marketing instrument with different effect, right? But you do not know the cost-effective relationship in the beginning, right? So you need to do some assumption, isn't it, right? So you have this prediction and assumption, and you do the simulation, right? And after the simulation, you actually can identify the optimal operation, right? Okay, so I want to use this type of coupon. I want to apply this coupon to this population of my customer, and then if I do that, I expect that I will have an expectation that their like average buying probability will raise by how much percent, right? And with that, I will have some extra revenue, and I will have some extra profit, isn't it? Right? And if that profit can justify the cost of the instrument, then I can use this instrument, right? And otherwise, I cannot use it, right? Okay? So next week, that's what we are going to do. I want you to let's go to the let's go to this week's let's go to the unit web page. Uh, this is what I want you to do, right? Next Monday, right? I would like you to prepare a 6-minute presentation with the title, What is Business Analytics? Okay? It's kind of like based on this slide, right? Based on this slide, I want you to prepare a presentation, okay, entitled "What is Business Analytics?" Okay, and I want you to, based on the slides that I just show you, and add what you have learned in this course, right? Try to annotate the slides by what you have learned in this course, and use the Tafan case as an example, right? Okay? Okay. For the rest of the course today, I'll prepare you for the Tafan case, right? By using model and assumption and prediction. Okay? And your presentation should like include whatever you have learned in this course, right? Like up to this point of time, we have do a lot of things on the Tafan data set, right? We have done exploration, okay, and today we are going to do some prediction, assumption, and simulation, right? And together they will give you a good, I should say, a complete, a complete idea about what is business analytics, and that is my objective for this course, right? Well, you might not be very familiar with each of the you may still remember this chart, right? Okay, so this is the typical business analytic type of thing. So you're collecting data and you using tool to do exploration, analysis, prediction, simulation, optimization, right? Nowadays we have a lot of R package, right? Which is specialized in each of this job, right? What we want to do is to like use R language. In this R language environment, we kind of connect the tool to build a analytic data assembly line, or I should say the business analytic assembly line, right? So you actually have a process to help you like do planning and present your planning, right? Isn't it? Right? So in our case, we are basically doing something like this, right? I should have a. We are doing something like this, right? We explore the data so we can set the focus and set our goal, right? And then we will do the prediction, right? Okay. Because of time, I do not have time to cover how to do that, but I will give you the model, right, to help you predict the repurchase probability and also the amount of buying, right, for each of the customer. But that is not enough, right? In order to choose instrument, choose target, and estimate the effect, you need to do some assumption. Okay? So today I'll help you make assumption, do simulation, and try to do the strategic optimization. Okay? And Next week, I would like you to like try to give a presentation of what we have learned, right? Try to stay in a systematic, holistic label. Try to present what you have learned in this course. Okay? Do you think 6 minutes is good enough for you? Do you want longer? What is your opinion? Like, no less than 8 minutes. No longer than 8 minutes, right? Let me give you some buffer, right? So you can prepare a presentation, okay? And just like in our midterm, right? And in the beginning of next week, I'll let every team like do your presentation, and after that, I will kind of like wrap up the course. Okay, that is the plan. Okay, so for the rest of the course today, I will walk you through this part. Okay, in 2 hours. Okay. Question or any comment about our final? Wait.
Professor, may I ask, like, from the website you say we need to upload the video files. So do we?
No, you don't need to upload the video file. Next week you just come up and do your presentation. Okay. Okay. So let me I just copy from something. So don't need to do the video. Do you prefer to do the video instead of going up and do the presentation? If you do the video, then you just play the video. You don't need to do the you do the live presentation. Which way do you prefer? Who would prefer the video? Like, raise your hand. So you actually prefer like live presentation, right? Okay. So you have time for each of your member to say something, right? Okay. Good. Okay, so that is the plan. Let's take a break, right? Let's take a 10 minutes break, and let's be back at 10 after 10, okay?